What if you needed to process 1,000,000,000 numbers, but only had enough memory for 1,000? In Python, a list comprehension is eager. It computes every value immediately and stores all of them in memory before you use a single one. Generators work differently. They use lazy evaluation, meaning each value is computed only when you ask for it. Nothing is pre-calculated. When you define a generator, you are defining a recipe, not the result. When a generator yields a value, Python pauses execution and hands that single value to the caller. The rest of the sequence does not exist yet. Call next again, and Python resumes from exactly where it left off, producing just one more value. Your memory footprint stays nearly constant whether the sequence has 1,000 or 1,000,000,000,000 items. Contrast this with a list. A list allocates all its memory up front before you access even the first element. With 1,000,000 records, every item lives in RAM simultaneously. Generators break this constraint entirely, and they also unlock something lists can never do: infinite sequences. You can generate values forever without ever running out of memory. Generators use lazy evaluation to produce values on demand, keeping memory constant and making infinite sequences possible. Next, try converting your heaviest list comprehension to a generator. Want to nail questions like this in your next interview? Interview Mentor gives you hands-on practice with real questions. Every answer gets a grade with specific, personalized feedback. Track your progress across topics and difficulty levels.